Okay, let's start this topic, alpha beta pruning. Yesterday, we finished at this slide, alpha beta pruning with the multiplayer, you can say. And now actually we are going to learn the alpha beta pruning algorithm, how it will execute, etc. Is it screen is okay with this slide? Okay. We can either start with this algorithm directly, or we can get an idea from this diagram. So let's take an idea from this diagram first. It will give you a little bit better understanding. Let's see that. So in this diagram, if you will look over this part A, then normally in the previous slide, we said that we have the alpha and the beta variable available in alpha beta pruning algorithm. And the maximum value for alpha is minus infinity. And the optimal value for the alpha is minus infinity, or you can say initial value. Initial value for the alpha is minus infinity, and the initial value of beta is positive infinity. So here, at the root of this small tree, at the root, we have alpha. This is the value of the alpha, and this is the value of the beta. When this algorithm will go into the branches of this tree by using the depth first search, it will go like here. It will go to the B, and then it will open up the first branch of this tree, and it will calculate the value of it, and that value will be updated back to the parent of these children nodes, to the parent of these leaf nodes. So after opening it, now here the value of alpha is minus infinity, positive infinity for the beta, and it is here the values are updated. How? It will open up the child of this B node, and then the value is 3. That value will be updated for the 3. So this is the value of the beta. This root is for the max, and these are for the mins. If you will go behind, maybe you will see this is max and this is min level. This is the level for the min player. So now the value, the minimum. So after opening its first branch, it will update the value of beta, which is the value for the min player. Then in the next step, it will open up the next branch. That 12 would be higher than this 3, so it will not accept. The min player will not accept, and the minimum value will remain 3, which is minimum value is represented by beta, maximum value is represented by. So this is the value for the max player, and this is the value for the min player. Max has the alpha variable, min has the beta variable. After that, it will open up the third child, and the value is 8, which is still higher than this 3. So it will not update. It will not be updated, and the value will remain 3. When all the children will be evaluated, then the final value that this node has, that value will also be updated in the alpha. So, and then that value will also be updated at the root node. So here you can see the value of alpha is now 3, also available here at this node. After that, it will open up the next node, and then it will open up the first child. The value is 2, so that value is updated here with the beta variable, with the beta variable. So the value of beta is 2 here. As the alpha has already the value 3, if from this node, if this next node has value 10 or 14 or 10, whatever, this min player will not allow to accept those values, huh? Because it is more than 2. So it will not accept. It will accept 2. But if it will have 1 or 2, if it will have 1 or 0, then min will allow to update this value. But 2 is higher than that. And this 2, alpha already has that 3. So alpha will not accept even this 2. Alpha will not accept even this 2, which is the value of this branch. So the point is there is no need to open these two further children of this node C because alpha has already 3. So due to this reason, it will skip these 2 branches. Alpha beta pruning will skip these 2 branches and it will jump over. It will go back and DFS will execute the next uh, subtree for the node D. It will open up the values. You can see the value of alpha is still 3. Here, here it here we are just mentioning, huh? It will skip, and here now it will open up to. Okay, now the value of beta will be 2. The value of beta will be 14 here. But when it will open up this 5, then the value of beta will become 5 here. And then when it will open this branch 2, the value of beta will become 2 here. So this is the only final step is displayed here. And there are some steps which are not displayed here in this figure. Okay. So you don't have to worry on this situation because the step of 14.5 is not displayed here in this diagram. Only after evaluating all the children, only the updated value with 2 is displayed. When this beta is 2, this also becomes the value of alpha. It will be propagated to the root or not? This is a question because alpha already has 3. So from all these, it will not accept this. So this is how it will go on. This is how it will go. It will not accept even this 2. So it finally, the value of alpha and beta would be 3. So finally, at the root node, the value of alpha and beta would be what? 3. And then this algorithm will go out of its execution. But here we have an example that this algorithm will skip these 2 branches. This is a small example. And in this example, you have only one evidence that some branches are skipped. Some branches are filtered out. Some branches are pruned from this tree. If your tree is much bigger than that, according to your problem, then you can see many branches will be filtered out from the game or from the search tree of your problem. Anyhow, we will take this example later on. We will run this example later on when we will execute this algorithm. So from that previous example, we have learned something. We have learned something that this alpha beta pruning algorithm, when it will execute, it will update the value of the alpha and beta. When it will execute, it will update the value of alpha and beta. And it will also prune the branches at some nodes where the condition will met. Where the condition of pruning will met, it will prune the remaining branches of the node. It will filter out those branches, and it will go like that until as soon as the values are worse than the current alpha and beta value. This is the pruning condition. So it prunes the remaining branches of the node. It will filter out the branches of the node when as soon as the values are worse than the alpha and beta. Suppose you have some values of alpha and beta. If alpha has higher value and if the next alpha value is lesser, it will not accept, okay? This is what this statement is saying. This is what this statement is saying. And if you have some value for the beta, beta is something minimum. And if you have some higher value again, it will not accept. Some minimum value, okay, it will accept. So here we are using the word worse. We are not saying specific higher or lower, what worse. We are using general word, huh? We are using a general word that if the values of alpha, if the if you will have some value of alpha and beta, and if the next values are more worse than the existing values, then you can do something like that. Then you can prune them away for the max and the min player. Now, this is the algorithm. We are going to read it first, and then we will execute this algorithm over that small example. Here, alpha beta pruning, this happens most of the time with me. And it is. So the name of this algorithm is alpha beta search or algorithm. We are passing some node into it, and it will return us some action. What is first? Then we are calling this max value function, which is this one, and we are passing this state into it, and then the value of the. Okay, we can continue again, huh? I don't know what happened. Let's check me first. I don't want to take a risk, and then at the end we don't have our recorded video, huh? So I don't want to go into that state.